Hello, welcome to this fourth and final part of this series of comparing rights-of-way images. In this part, I'm just going to go through some hints and tips and also some advice on how to take photographs of maps, which you might have to do in particular to get hold of some images of the definitive map in your area. So when taking photographs of a map, there's really three main ways that you can get distortions of those photographs. This can be because when you're holding the camera, the iPhone, I'm going to guess, or some other, or maybe an Android, that you may have it tilted either side to side or top to bottom, or you may have it slightly rotated. So I'm going to talk about what that impact that has on the next three slides. So you can see here, exaggerated, this is what happens if it's not flat top to bottom. Either the top or the bottom will be wider than the other end. And obviously that's a distortion that you want to avoid. So this is the same as the previous slide, and in this case, instead of it being top to bottom, it's left to right, but really it's the same kind of distortion. So in exaggerated form, this is what happens if an image is rotated. And obviously that's something to be aware of and keep an eye out for, to try and cope with it if you do find it. There are four things that you can do to help you to take better photos of maps. You can use a stand to hold the camera. You can activate the grid and level functions on an iPhone. You can use a selfie stick clicker to take the photos. And you can photo a whole grid square, including the lines around it, the lines of the square. So here's an example of a stand that you could use. Obviously there are other models available. It doesn't have to have a built-in light, but it's worth mentioning that lighting is something you need to be careful of. You can take photographs of things near a large window. And natural light's quite good because it comes from different directions, and as a result, you don't get so many shadows. The advantage of using a stand is that you can set it up in terms of tilt, left, right, top, bottom, and rotation, and then all you have to do is to take the photograph. So to help you get the camera level, top and bottom, left and right, then you can turn on these features on an iPhone, and this shows you how to do this. Basically, go to Settings, Camera, and follow the instructions here on screen. I'm sure that there must be something similar available on Android devices, but I'm afraid I don't know anything about them. Once you have your shot set up with your camera on a stand, you then need to take the photograph. If you try pressing the button on the phone, it's going to wobble unless you have a very, very solid stand. So a tip here is to take one of these clicker things from a selfie stick and use that to take the photograph. And that means that the phone will be undisturbed, and so it won't wobble. When taking a photograph of a definitive map, it's best if you can to take a little bit more than a whole square, as shown in this image here. The advantage of this is that when you've got the grid lines in, you can tell whether or not you have put in any distortion. So you can see whether the distance here to here is the same as the distance here to here, and the same vertically and so on. And if these lines are not perfectly horizontal and vertical, then you'll know that you've managed to rotate the image a little bit. Sometimes it can be hard to fix that, but it's all the better if you know about it. I think you need to be aware of the sources of inaccuracy, so I've listed some of them here. Now, when drawing a path on the definitive map to add to another map, I've said part 1 here, is also part 2 for that matter, how accurately you draw that path is going to make a difference. So do take care to do that as accurately and carefully as you can. Measuring between landmarks on two maps that you're going to place one over the other, two maps or images, again, that's an obvious source of error, so you need to be as careful as you can and try and get that pixel perfect as well. One or other map might actually not be the same scale vertically as horizontally, so do be alert to that, in which case you just need to scale it slightly different in those two different directions. Most maps are pretty good in this respect. The distortions mentioned above when taking a photo, camera not level or rotated. The maps themselves might contain inaccuracies. Now, OS are very good, but they're not perfect, and sometimes things are not actually where the map says they are. So there are mapping errors that you need to be aware of. Definitive maps all have some errors on them as to exactly where a path goes. This might come as a bit of a surprise, but it's perhaps not a surprise when you think how big a job it was creating these definitive maps. So quite often when you look at it in detail and you know about it, you realise that a path's been drawn to go down the wrong side of a field boundary, for example. A path may well be along an old track drawn on an old OS map, but you can't rely on that. It's often the case that that's exactly where the footpath goes, or right away, but sometimes one or the other has drifted, and that is something that you have to be aware of. It's the line of the definitive map that matters. It's not where it should be, it's where it is. And finally, on the National Library of Scotland maps, which are a terrific resource, some of them can have a slight rotation, and that again is one of the rotation issues, or one of the distortion issues you need to be aware of. So be careful, be skeptical, and strive for the best possible results. What accuracy can you expect? I would say that if you use the methods in part 1 and part 2, that their accuracy is not brilliant. It's not bad, but it's not brilliant. I would think that sub 5 meters, I would say, is something that you can achieve. You can perhaps get that down to 2 to 3 meters if you take a great deal of care, and perhaps redo it a number of times to see if you get a repeatable result. These methods are free, which is a big advantage of them. Now, the method in part 3, we can get to a much higher level of accuracy, perhaps down to 1 pixel with care. So this means sub 1 meter accuracy, perhaps even down as good as 300 millimeters. So this method, though, does have a significant cost because you have to buy the up-to-date map, and that's roughly £25 is what I paid for a map. I hope you found the videos of this series helpful, and I'd like to wish you good luck in matching your maps and finding where those paths really are. Bye now.